This is the second of two videos on the normal curve. So we're going to look at normal tables in particular. We talked about the area under the curve before, and all the tables do is give you a more precise value. And there's a number of different types of tables. I'll show you two. There's one on the left and one on the right. Looking at them, as you look on the right, on the left, for example, if you look, if you look at one standard deviation, you'll see it's 34%, and that is what we talked about last time. And that is measured, it's this area. It's from the mean, either way, left or right, to the z-value. Looking at the z-table on the right, if we look at one standard deviation, you can see that it's 16. 16 is the area to the left of the z-value, and in this case it's always negative, the z-value is, but it doesn't matter, it's all symmetric. So you can see that it gives you the same solution, just if you add them up, they add up to 50%, which is what you'd expect. Okay, let's do an example using the tables. We have rainfall, mean 30 inches, standard deviation 5 inches. We always want to keep in mind how we convert from from an x value to a z value. And we're going to find the probability of the rain greater than 32 inches. So to do that, we first look up the z value of 32 inches, or we calculate it. So it's 32 minus 30 divided by 5, so that equals plus 0.4. And I failed to mention, but as I recommended in the last video, you should always set your a sketch of the normal curve with your z and x values. So we're looking at, here's the mean, there's 30. We're looking at greater than 32, so something like this is the area that we want. Everything to the right of that line. Now, if it were to the right of 30, we'd know it was 50%, but it's not what we're looking for. We're going to find this area by going to the z-table. So z equals 0.4. Here we are. We'll use the table on the left, and I'm going to read down. My z-value is down. 0.4 is here, so it's about 15%. Just a note on how to read this. If I had, for example, a z-value of 0.47, then I'd read 0.4, and then I'd come over and I'd find, and that would be 18%, would be the value for 0.47. But we have 0.40. That's about, I'll say it's 15% to keep the numbers easy. So going back to our example, the probability at z of 0.4 is about 15%. So this means this area is 15%. That means the area we want is 50% minus 15%, which equals 35%. Okay. Let's do another one. Now we're going to find the probability that the rain is below 24 inches. So same thing, we'll find the z-value of 24, and that equals 20. So a z-value of minus 1.2. Now let's find that probability. Well, before we do, let's remind ourselves what we're doing. So here's the mean again. Minus 1.2 is out here, 24 inches, minus 1.2, both the same thing out here. And we want the probability that it's less than, so that's the area we want. And it so happens that the second table will give us that area directly. So if I look up minus 1.4, excuse me, did I say 1.4? If I look up 1.2, sorry, look up 1.2, here it is on the left, right table, gives us precisely the area we want, and it's 11%, so this answer is about 11%. Let's do the last one. So probability the rain is between 27 and 37 inches. Again, here's the 30 inches where z equals 0. 27 inches is going to be less than a standard deviation to the left, and 37 is going to be greater than a standard deviation to the right. So that's the area we want. Let's get the z-values. No, I'm sorry. Z-value of 27. Is negative 0.6. And the z-value of the 37 is 1.2. So let's go ahead and look up the probabilities of these. And for that, we'll use the table to the left. The minus 0.6 gives us about 23%, and the 1.2 gives us about 38%. So 23 and 38% about. And we sum those, and we'll get about 61%, because this area is 23 and this area is 38%. Thank you.